Alright, let's look at the homework 3, problem number 9. Alright, so we have the second order reducible differential equation, and in this case we have y missing. Alright, so what we can do is we're going to do the following substitution. We're going to let y prime be p, right? And of course, if y prime is p, then y double prime would be p prime, right? So let's rewrite that equation here. So we're going to have, let's see, x there. Right, y double prime is p prime. I'm going to write it as actually dp over dx. And this is equal to y. So y prime, which is p. Right? So this is a separable equation. So I'm going to divide through by p and also divide through by x. Right? That way we're going to get the 1 over p dp over dx is equal to 1 over x. Right? Then we can just integrate both sides with respect to x. Integrate both sides with respect to x. And we can cancel dx on top and dx on the bottom. Then antiderivative 1 over p is a natural log of absolute value of p. Right, and this is equal to another natural log of absolute value of x. Right, and I guess it's going to be plus some constant c. I'm going to call it c1. All right, then to get rid of natural log, I'm going to raise e to both sides. So you have natural log of absolute value of p is equal to e to the natural log of absolute value of x plus c1. Right, and we can cancel, right, e and natural log. They're inverses of each other. And I'm going to actually rewrite this guy as, let's see, we have e to the c1. So I'm going to write the e to the c1 first times, actually, e to the natural log. So it's going to be an absolute value of x. Right, so we have that. Right, then since I want to get rid of the absolute value sign, so to scratch absolute value sign, I have to consider positive or negative. Right, and we can actually scratch this absolute value sign as well. Right, then I'm gonna call this a big constant, say c or something like that. All right, so what we get is going to be simply, right, p is equal to cx. Right, and remember that p is the derivative y prime, so we're talking about dy over dx. So what we can do is take the antiderivative of both sides, so you get y, and this is going to be equal to, so c is here, antiderivative of x would be x squared over 2, and then you have a plus some constant d or something like that. Right, so d is a constant. Right, to make it look a little bit better, I'm going to actually call c over 2a, and this guy b. Right, so therefore y is equal to a x squared plus b. Right, so that is the solution of the differential equation. All right, that's it. I hope that this was clear.